what did we say? We said from negative infinity until we get to A, that intersection point, which has an x-coordinate is 1.667, open parentheses. And then again, starting at the second intersection point, B, which is 5.892, and then going on forever. So the solution that we're looking for is negative infinity to 1.667 and 5.892 to infinity. That's our answer to F. Let's move on to G. For what values of x will the product f of x times g of x be greater than 0? Well, again, let's go over here and think about numbers. If a times b is greater than 0, that means that a times b is positive. The only way I can get, well, there's two ways. There's two ways for me to get a positive answer in multiplication. That would mean that a is positive and b is positive. The second way is that a is less than 0 and at the same time b is less than 0. So over here, if f of x is greater than 0 and g of x is greater than 0, we'll have a solution. If f of x is less than 0 and g of x is less than 0, we'll have a solution. Let's go to our graph. Where is f of x positive and at the same time g is positive? Well, let's see. F is positive in between the roots, in between 1 and 7. And I can see, if I look just between where x equals 1 and x equals 7, the red graph is also positive. So on that interval, the interval 1, 7, we have a solution. I also need to consider where f of x and g of x are both negative. Let's see, g of x is negative starting over here at 7 and continuing forever, but the graph of the cubed root of x strictly increases, so no solution over here. If I go to the other end, f of x is less than 0 from negative infinity up until 1, but the red graph is negative from negative infinity to 0, and then from 0 to 1, the red graph is positive. Since I need them both to be negative at the same time, then I'm going to look on the interval negative infinity to 0. And so the final answer should be negative infinity to 0 union 1 to 7, and we're going to put a bracket around that. Okay, not bad. Last one, H. On what interval will f of x divided by g of x be less than 0? Again, we can go over here on the side. If we have two numbers being divided and the answer is negative, then that means two things. A is less than 0, the numerator, and b is greater than 0, or the reverse. A is greater than 0, and b is less than 0. What that means for us in this case with the functions, we're going to look to see where is f of x less than 0 and at the same time g of x is positive. Sorry about that. And then we're also going to look to see where is f of x positive and at the same time g negative. Let's take it one case at a time. If f of x is negative, f is below the x-axis. And at the same time, we need g of x positive. We need the red above the x-axis. And the only place where I see that happening is from 0 to 1. F, the blue, is negative. G, the red, is positive. So that gives us the interval 0 to 1. Now we need f positive and g negative. Well, f is positive from 1 to 7. On that same interval, g is also positive. So what that means is that there actually is no solution. There is no interval where we're going to have f of x greater than 0 and g of x less than 0. So our final answer will be this interval 0 to 1. Well, that's it. Congratulations, you survived another video I hope you find this helpful. I hope this gave you some nice examples of pulling a whole bunch of different ideas together. We looked at inverse functions, we looked at combinations of functions, we did some graphical analysis, we did the composition of functions. We've got a whole lot of skills built into this one problem, and this is exactly the kind of thing that we would expect you to be able to do, say, on the trimester exam or on the unit test. Anyway, good luck to everybody.